Magnetic field and field lines. So, before discussing the magnetic field and the field lines, we need to understand about the device that you see in front of you. It is the magnetic compass. It's a magnetic compass which gives you the direction of North Pole and South Pole. Okay, let's see. The ends of the compass needle point approximately towards north and south directions. Okay, we have a geographical North Pole, we have a geographical South Pole. With the help of this magnetic compass, you can decide which direction is North Pole, which direction is South Pole. A compass needle, and see, it's important that you understand how is this compass needle working. So, this compass needle, this needle itself is made up of a small bar magnet. It is made up of a small bar magnet. See, a compass needle is a small bar magnet. Okay, we'll understand how is this compass working with this, that through various activities we have observed that like poles means either north pole of the bar magnet or south pole. So, like poles repel, that means north and north pole of the bar magnet will repel, while unlike poles, what are unlike poles? North south is the unlike poles of the magnet attract each other. Okay, let's see what is the meaning of this. Suppose this is your bar magnet. The bar magnet has two ends. One end is North Pole, other end is South Pole. Okay, now if you bring another magnet such that this is the North Pole and this is the South Pole, what will you observe? That these two magnets, they will repel each other. They will repel each other because both north and north are like poles repel each other. Similarly, over here, if you have a bar magnet which is like this, these two poles, they will attract each other because they are two different poles. This particular idea has been used for developing magnetic compass. Now, this is your magnetic compass needle. Okay, now this compass needle is in itself has north and south pole, right? The bar magnet is there, and of that bar magnet we have a north pole and a south pole. Now, you know, Earth also has magnetic behavior. Earth is also like a magnet. So, Earth is like a magnet and Earth south pole, Earth north pole is magnetic south. Earth's south pole is magnetic north. Okay. Now, when the needle is placed, obviously this is the north pole and this is the south pole. Imagine that these are two magnets. Earth is a magnet with polarity as south and north like this, and this is your bar magnet, north and south. So, when you place the bar magnet, obviously the north pole of the bar magnet will be attracted towards the south because unlike poles, they attract each other. So, this is how the magnetic compass tells you the direction of north and south. The attraction of the magnetic compass with respect, because of the Earth's magnetic field. Earth's own magnetic field is there. Okay, let's understand again. See, this is your Earth, which is also like a magnet. This is the north pole of the Earth, but when it is a magnet, this is the magnetic south pole. Magnetic south. Okay, and this is your magnetic north. Okay, now suppose you bring a bar magnet, a magnetic compass. Your magnetic compass in itself is a bar magnet and it will have its own poles, north and south. Now, if it is in the Earth's magnetic field, obviously north pole will be in this direction and south pole of this is our compass, right? Now obviously north pole of the compass will be attracted to the south pole and this south pole will be attracted towards the north pole. Okay, this is how a compass behaves. That is why the compass is telling you the north direction, because its north pole is attracting to the earth's south, magnetic south pole. You can call this as your magnetic south, this is magnetic north. Okay, this is how your magnetic compass is acting.